In this video, we are going to be doing this question on momentum, which is from the Physical Sciences Paper 1 DBE November 2023 exam. So, without wasting any time, let us dive straight into it. A wooden trolley of 2.7 kilograms moves to the left with a constant velocity of 3 meters per second. A bullet of 0.03 kilograms is fired horizontally from the left towards the trolley. The bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. The average force exerted by the trolley on the bullet during this time is 591 newtons. The bullet-trolley combination now moves to the right, but we have not been told whether at what velocity. Furthermore, we are instructed to ignore all frictional and rotational effects. Okay, so the first question is write down the magnitude and direction of the average net force that the bullet exerts on the trolley. In the statement, we were told that the bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. Of course, if something comes to rest, it means that it goes to a complete stop, which means that its velocity changes to 0. Furthermore, they did tell us that the average net force exerted by the trolley on the bullet during this time is 591 newtons. So question 1 is very straightforward, and you can also tell from the mark allocation and the fact that we are being instructed to write down. So no calculations required at all here, but we simply need to apply Newton's third law of motion. And from Newton's third law of motion, we know that if object A applies a force on object B, object B will apply a force of the same magnitude to object A but in the opposite direction, which is exactly what is happening here. So to answer question 1, since we know that the trolley exerted a force of 591 newtons on the bullet, it means that the bullet is also going to exert a force of 591 newtons on the trolley, and the direction of that force is going to be in the same direction as the movement of the bullet, therefore to the right, and you get your 1 mark easy like that. Moving on to question number 2. Now we must calculate the magnitude of the velocity with which the bullet strikes the trolley. This bullet came to rest after striking the trolley, and we also know that this took an amount of time equals to 0.02 seconds. So what we can do to answer this question is we can apply Newton's second law of motion in terms of momentum. And we know that in terms of momentum, F net is equal to the change in momentum over the change in time. So the net force is the rate of change in momentum. And of course, the change in momentum that we are referring to here will be the change in momentum of the bullet. So it will be given by the mass of the bullet multiplied by the final velocity minus the mass multiplied by the initial velocity of the bullet divided by time. Now, in order for us to substitute correctly here, it's important that we choose a positive direction and clearly indicate it. For an example, we can take to the right as the positive direction. And if that's the case, we were told that the average net force that is exerted by the trolley on the bullet is 591 newtons. And it's very important that we keep that in mind, because the net force that we need to substitute here is the net force that is acting on the bullet, not the net force that is exerted by the bullet on the trolley. Therefore, the direction of this net force that will be acting on the bullet is going to be to the left, meaning that it must be negative here based on our positive direction. So here we are gonna have negative 591, and as given the mass is 0.03, we were told that the bullet comes to rest, so the final velocity is 0 there, and then we minus 0.03 into the initial velocity multiplied by the initial velocity that we are trying to find. We know that the time taken was 0.02. So obviously this term will diminish to 0 and the negative signs here will cancel out. So we simply need to use a calculator to get the final answer. So I'll just take 591 and multiply it by 0.02, get the answer, and then I'll just divide that answer by 0.03. So the initial velocity for the bullet was 591 meters per second. So that's how you can work out question number 2. Now let's move on to the next question. Well, there's nothing special about question 3 because it's just the definition for the principle of conservation of linear momentum, which is straightforward, but of course it's very important to understand what it means, because in question 4 they are asking us to calculate the magnitude of the velocity of the bullet trolley combination after the collision. And to answer this question, we need to apply this principle of conservation of linear momentum. And mathematically, we know that the principle is telling us that the total momentum before the collision is equal to the total momentum after the collision, provided that this is an isolated system. And how do we know whether or not this system is isolated? Well, we were told to ignore all frictional and rotational effects. Now, in this case, we can see that before the collision, we had the bullet moving to the right and we had the trolley moving to the left. So we can still use the same positive direction, which is to the right. But before we get into the substitution, let's actually expand this formula. So the total initial momentum is going to be equal to the mass of the bullet, so I'll call that B, multiplied the initial velocity of the bullet plus the mass of the trolley multiplied by the initial velocity of the trolley. And since after the collision the bullet and trolley became a combination, the final momentum is going to be given by the mass of the bullet plus the mass of the trolley, so their combined mass multiplied by their velocity, so their final velocity, because they will move together as a combination. So we can simply express the final momentum like that. Now let's do the substitution. The mass of the bullet is 0.03 and the initial velocity of the bullet is 591 as we had found it in the previous calculation. When substituting here, we'll give this a positive sign because we have taken to the right as our positive direction. For the trolley, we have a mass of 2.7 kilograms and its initial velocity was 3 meters per second, but to the left, therefore it's -3. And then for the combined mass here, we'll have 0.03 plus 2.7. And so our only unknown is the final velocity. So all that is left is just an easy math problem. So I'll quickly do it. in the calculator. So we have 0.03 multiplied by 591 plus 2.7 multiplied by -3. So this is equal to 9.63. Now I'm simply going to divide that answer with 0.03 plus 2.7, and this will give us the final velocity of the bullet trolley combination. So it's 3.53 meters per second. And just like with the previous calculation, we were simply asked to find the magnitude, so this will be the final answer. Okay, so that's it for this video. As always, if you have found this helpful, which I assume you did if you have watched up to this point, please make sure that you like this video, share it with your classmates, and subscribe to the channel if you haven't done so. If you've got any questions, you are more than welcome to leave me a comment down below, and I will make sure that I check your question. Otherwise, that's it for this one. I hope to see you on the next one. Goodbye.